And to be able to do it, I just want to go through some ways you could actually go about writing these expressions and saying things, what's happening as an equation for this. So if we've got something going on inside the bracket, that's going to replace the x part. So what we're actually going to have is everything inside the fx replaces the x term, x plus 2, and then add 2 on the end. So this x plus 2 replaces the x that was in the original equation. Multiply it out and simplify. So we get 3x plus 6 plus 2 is 8. Now it allows me to actually replace what's in the function. If it's something happening outside, what we can do is we can take the original expression, 3x plus 2, and then treat that as if it's going into this 2. So we replace the fx with the expression. So fx goes in to a bracket and we multiply it out. I'm recording it as well, Arajan, so I'll upload if it's a problem. The 2 expands into the function, so we now get 6x plus 4. So we can replace the values by multiplying into the function. Let's take another one. If I've got f of a minus x, we're going to replace the x in the expression with minus x plus 2. So we multiply through, and we get minus 3x plus 2. Let's do one more. If I've got fx is 2x plus 3. Yes, Camilla? Can't hear me at all. Okay, so this last one, we've got 2 layers to do. We've got our expression, the 3, replace the x with 2x plus 2, then the whole function itself we are adding 3 to. So expand the brackets on the inside first of all to give us 6x plus 2, and then add 3 to it to give me 6x plus 5. That's the how you can play about and get expressions for functions. The other part of the exercise is if you are told a point on a curve is at 3, 7, so this is the function. When x goes in as 3, we get the answer 7. That's what this is telling you about the function. If I'm asked to find out what happens when I do a half of f of 3, that means the y value is half as big. So that is going to be 3.5. If they're telling me what happens to the point 37, how does that translate? So this now actually moves this point to being 3.5. X is 3 and 3.5 is a new point. If I take that point and say that we're doing a transformation of a half inside the function, remember that's actually saying the value when we're inside the function is going to be halved to give me 3. This tells me that the same point on my graph is going to be, remember, inside the function, twice as far. So in this case, we're going to double it in the x direction to give me 6, 7. It's the new point. Okay, so there's the exercise. Exercise 26.4 to start, and then do some transum sketches. You need to do screenshots showing comparisons of what they give you. So if I show you one on there, this is the function they give, and if I'm doing fx minus 2, moves all the points down 2 places. So I've got that point. This all moves down 2 places, so it'd come down to here, come down to here, come down to here, to just over there. And we can sketch through the function, tracing what's above, and trace as close as we can to what happened above it. And trace on down. And then if you show your transformation, I was fairly close. I'd screenshot that and put it into the notebook. Okay? That's the work for the day.